technology expert. And these are just a few of his accomplishments. And this is what his talk is going to be. And so it's got to be a fun talk, because how could you not have a fun talk with fun in the title? So thank you so much for coming, Josh.
Thank you. So it's truly an honor to be here. I hope to keep this relatively brief, and we can have a Q&A session afterwards, or I can answer your questions individually and return you to your life already in progress. So if I can figure out how to switch over. I am not a Mac expert. Oops. All right. Thank you. I will attempt to do some other computer tricks later. So, as Trish mentioned, this talk is about recycling data for fun and money, and I hope to cover both of those. As you can see, I am not the world's best PowerPoint expert, so bear with me for the graphics that you'll find in the presentation. So first off, what is digital exhaust? And before I begin, how many people are in the online advertising industry? Less than a handful. Okay, that's good, because this talk is actually structured to be at bring everyone up to speed before I get into any of the fun stuff. But if we look at what data is being collected, traditionally it was collected off of computers, and now we're collecting it off of additional devices. Some of those happen to be mobile devices or portable devices. There's also data collected off of things that we don't normally think about. Today it's maybe television viewing habits. We've all heard of Nielsen, and there's a bunch of these other types of measurement companies that are helping advertisers understand what people are interested in, what type of content, and at the end of the day, that helps support a lot of the content that we enjoy for free. Now, there's also plans in place to have tracking and data collection in automobiles, and the latest one I heard about is on refrigerators. And yeah, I kid you not. And I have seen a kind of version of that, which was very low tech, but essentially you scanned the barcodes as you put things into the refrigerator, and would help you generate a grocery list as looking at replenishment rates for milk and cheese, et cetera. Just a kind of easy push button that this is the stuff you tended to buy. This is probably the stuff you may want to be buying in the future, and you could edit the list on this device. The unfortunate fact is that most of the data ever generated is lost. It's either stored in dusty log files, or it's kept up in these huge, we heard about the big data, right? And it is very big data. It's a lot of data, but it's so big that most of it is not actually very usable. So, wouldn't it be fun if every time we were using these devices, they got smarter? And concept designers call this wear in as opposed to wear out, so it gets better and better with use. And some people actually sell pre-used jeans and previously owned cars. I'm not sure the cars are any better, but it is a concept. And the nice thing about this kind of circular process, and that's why I chose recycling as part of the talk today, is we truly can begin to offer people better content, better personalized experiences, if we can share the information that's being thrown off just through our daily use. So wouldn't it be even nicer, and this is the fun part, if our browsers got smarter when other people are using their browsers? So this is, we've seen kind of the social network take us by storm and kind of change how we viewed the ratings of quality. If you look back in the day, it used to be a pay-for-placement was the notion of quality. If you could afford to have a takeover of the New York Times, full-page ad, you probably were a big company and you were buying, quality and buying that reach and buying that distribution. And then, with the digital version, right, you used to be able to pay Yahoo to have a larger logo show up in the listings. It's still a manually edited list of sites that people might want to go to related to a given topic. But the ones that bubbled up to the top, people paid a little bit more to be up at the top and in larger font. And then, some guys came around, said, well, maybe there's another way of rating quality. And what if we had just the content itself? So the links between all these different publisher sites be the votes of what is important. So, Google, it famously came up with that approach to to creating quality. And we recently saw that there's another way to view quality. And the social networks, instead of having editors, instead of a few editors that we used to have as our broadcast editors or newspaper editors, we democratized it to website publishers, and then we further democratized it to us. Right now, everybody gets to vote with their like buttons or even within their social network, sharing tweets, what is quality? But we're still not closing the loop on that. And so I still think we're in the infancy of where this technology will take us. But the end goal is to basically help us find what we're looking for better and faster. So unfortunately, all this big data is very expensive to process. So it'd be, I don't want to have to personally pay Google to process the web to find my results. So it is nice that we don't have to pay for any of this. And so that's where the money side of this comes in. Most of the content online, as everyone knows, is advertising sponsored. So we'll talk about that as well. So first, since there's very few people who actually understand the digital advertising space, I will try to make it a little bit clearer. First, publishers create content to attract people to come to their website so they can make some money. And marketers try to reach the desirable audience in the right content, or context it's sometimes called. So you've got the publisher attracting the visitor, and we are monetizing it with these messages. So that the whole technology on the matching side is trying to find which ad banner should we be showing to which individuals in which context. That's kind of the marketer side of this equation. And if you look at how they pay for it by the thousands. So the standard metric of how they pay to get their ads listed or presented to visitors is called effective CPM, cost per thousand. And yes, thousand is with a T, but they use the Latin, cost per mille. So everyone kind of backs out to an eCPM payment model, even if they happen to pay per click or pay per action. So another interesting shift is Google said, well, you don't have to pay for the placement for the broadcast. You get to pay only when someone clicks and they show up at your website, or at least they click. They don't always show up. So they began popularizing this cost per click, and the banner side of the house, which is these graphical ads that everyone sees, or the video ads, soon adopted that as well. It may have come out about the same time, but essentially saying, you only have to pay when someone clicks on the banner. Now, there's a problem with that, because if the marketer is choosing the content, they could say, in this instance, it's a Jaguar, and they could have put next to it free beer, right, and everyone will click. Of course, you may be getting a lot of irrelevant people coming to the website expecting free beer when, in essence, they're trying to tell you more about their car. On the other side, they could say, don't click, right? Horrible things will happen. This will download a virus. And they could still say, Jaguar preventing you from don't ever clicking here, right? And they could get their message out for free. So there's a little bit of a trade-off of, the marketer, when they only pay for people clicking, how much is there a call to action relative to just saying, here's my brand. Pay attention, but please don't click, because then I have to pay. So there's a little tension there. And then the cost per action model is after the fact. So I exposed someone, and days later, they actually bought the book that I was advertising to them or the shoes that I wanted them to come buy. So this cost per action model, and we'll talk about how the data is collected in a second. So here we see the marketers. They've got some content. They want to reach the right people, and then they have to figure out what sites do they want to put this on. And there's an ad server that helps the marketer figure out which sites are attracting the right types of audiences so that they can maximize their ROI, return on their investment. So if we look at it from the publisher side, so they're creating all this content, and they need to monetize it. So there's really just two sides to the publisher equation. One is to have relevant content to attract lots and lots of people coming back many, many times. So that gives you a lot of inventory and traffic. And again, back to our car metaphors, and publishers also have these things called roadblocks. There's a whole bunch of auto analogies somehow mixed into our industry. But anyway, they're trying to get all this traffic come to the site, and then they got to monetize it. So the monetization is the eCPM we saw, how much someone's going to pay, and then what % of all those impressions they actually sell. So that second half is called the fill rate. And they, of course, want to sell all of them. And they do this through a number of different mechanisms. First, they have a direct sales team if they're large enough. So Yahoo, one of the largest sales teams out there, is saying, please, Mr. Advertiser, come put your ad banners on my website, and we will ensure that your message is reaching the right people as we mutually define right. The problem, though, is that there's more inventory than a direct sales team usually can sell. And if you believe in the laws of supply and demand, when you have more supply than demand, prices tend to fall. So there's a second tier monetization path for publishers, which is the indirect sales team. So traditionally, they give it out to ad networks. So ad networks said, well, I'll help you monetize some of those pages that your direct sales team can't monetize. Or if you're a small website, I'll aggregate up your Joe's Autoblog with Sam's Autoblog, and we'll be able to attract an advertiser like Jaguar or Ford to come advertise. Because individually, they can't do contracts with millions of small websites, but they can do a contract with this aggregator of the inventory. So then they began to also help the larger publishers with what was called remnant, what was not sold through the direct sales team, and they began to sell it in slightly different manner than the direct sales team was. So because of the channel conflict, if I can get it cheaper through an indirect source than a direct source, well, then why would I ever go through the direct source? So they often would fragment the inventory and give certain areas to the ad network, or they'd change it. They'd say, well, you can sell it, you just can't mention my brand. Or you have to roll it into a package that is mixing in other people's content. So it's slightly different forms of monetizing that same content. So that's the publisher view of the world. So the question is it a zero-sum game? So when an advertiser is trying to place their ad, and we're measuring it by eCPM, so let's say it's $1. And by the way, the eCPM, the 1,000, the typical response rate is about 1 click for every 1,000 impressions. So really, if I pay per 1,000 or I pay per click, it's almost the same rate, which is also kind of a measurement of how good our technology is right now. So we're right 1 time out of 1,000, or we're wrong 999 times out of 1,000 of these ads. So we want this technology to get better, because right now, if we were wrong 990 times out of 1,000, it'd be a 10x improvement. So right now, it's a zero-sum game, or people think of it as a zero-sum game on each of these impressions. In fact, there's this rise of what's called an exchange. So just like we have the New York Stock Exchange or the NASDAQ, where it's a public marketplace and people can buy and sell, there's now these public exchanges or semi-public exchanges for advertising inventory. And it's being bought and sold, and there's a highest bidder, and it's a second price inventory, second price auction, like with the Google side, where you only have to pay the price that the second person won if you're the highest bidder. So the notion that it's a zero-sum game is actually, I think, a false notion. So if you only look at it as every single impression, it absolutely is. If I pay $1 more as an advertiser, then that's going to cut into my ROI. If I could have gotten it for half the price and I got the same response rate, then I would have doubled my ROI. Likewise from the publisher, if I can collect another $1, I'm going to have higher yield. It's the same inventory, I'm just getting more money for it. But if you look at it more as an iterative game, then it looks a little bit different. So if you can actually deliver that higher performance, if we can go from the 1 click to the 10 clicks per 1,000, right? An advertiser may be willing to pay 8 times as much. So they're getting a better deal, they're getting a higher performance, and they're getting a better ROI. And on a per impression basis, actually the publisher's making more money. And as consumers, we're actually, if we're clicking 10 times more than we used to, we're actually seeing more relevant ads or content. So I think that there will be a shift towards more of this iterative game theory, as opposed to the way the market currently mostly operates, which is this zero-sum per transaction analysis. So if we were going to try to recycle all this data, what tools would we need? The first is really a problem of cardinality reduction. We have, if you look at search terms, I think the number of search terms that more than one person searches in any given month is on the order of about 50 million. If you're at Google, or it's a pretty large set. And of course, there's a zip distribution or long tail in almost everything you look at online. So very, few searches have 80% of all the people generating them, and in the long tail, there's only 2 people searching on that. But it would be nice if we could reduce the sparsity in our matrix by grouping together these similar concepts. Likewise, on the user side, it would be useful, instead of treating everyone as a unique anonymous identifier, if we could somehow group people into these related sets. And we'll talk a little bit about both of those. But from a marketer perspective, we heard for a long time about one-to-one marketing, which I believe is actually not anything a marketer really, really wants, because they would probably have to have as many marketers as the people they're trying to reach. They don't really want to create unique content for each person on the planet. They tend to want to say one too many. It's kind of how we write code. We'd like to write it once and use it many times, as opposed to write a separate program for every single thing we ever needed to do. So the interaction of the people and the content is grouping together these similar behaviors, and we'll talk about that as well. So first to the content or the context, trying to reduce this cardinality. There's a few different approaches that people use. So originally, we asked all of the publishers, the people producing the content, please tell us, what is this about? It's a really hard problem to guess what this language is trying to communicate. So you wrote it, or at least you copied it. You tell us, what are you publishing to the world? So publishers put in their meta tags in the HTML, and that worked somewhat okay until people began to realize, well, wait a minute. If I put certain keywords in my metadata, then I'll get ads that pay me more money. So there was a little bit of a game theory going on of the publishers trying to figure out what were the magic words they needed to put to actually get paid higher rates by the advertisers, or to attract more visitors, because they'd show up in a different listing by the search engines. So the search engines began to pay less and less attention to what the publishers were telling them the page was about, and they began to try to understand what that page was about themselves. And one of the ways they did it is they used a bag of words approach. They come up with a topic like auto, and then they have a bag of words or the set of phrases that are associated with that topic. So if I see tires, then it's likely to be something related to auto. And if I see muffler, it's again something likely to be related to auto. And that helped. And it's harder when it's just a search phrase. Search phrases are, of course, the hardest because it's such little text to analyze. So if I say black Jaguar, right, that in absence of anything else, you really have no idea if am I talking about a car or am I talking about an animal. But if you notice that I'm clicking on a bunch of car links after I searched on this, then you can begin to guess that I'm actually in a car mode and show more listings related to that. So that worked pretty well, and they used a standard inverse term frequency to try to figure out what were the important terms on a page relative to all the phrases on the page. But one of the problems with the bag of words approach is it doesn't really understand the language. It's just statistical frequencies, and so it wouldn't really understand the difference between man bites dog and dog bites man. And it's just looking at how many counts of these words appear on the page. So it gets thrown off. It gets thrown off by sarcasm. It gets thrown off by a bunch of other things like misspelling. So people had a bunch of approaches to help fix this. What if we remove all the stop words? What if we focus on the core aspect? The first sentence of every paragraph is going to be more important. Or if it's marked up in HTML, with the header tags, that must be more important. So we'll pay more attention to that. But then again, we're relying on the publisher to tell us exactly, and they can game the system by putting special words in certain areas of their article if they were so smart and knew the algorithm that was being used to rate it. So that was one approach. So going back to the disambiguation and the statistical frequency, some people came up with language parsing. So that would actually say, all right, this is the subject, this is the verb, this is the direct object. And that works really, really well. It's really, really hard. And the problem is it's language dependent. So for every language out there that people are searching and reading, I've got to go figure out all the grammatical rules and encode them. And that's a really hard task. So it was probably the most accurate if you could get that right. If a computer could read anything like we read things, it might get the humor. It might figure out, OK, I've got a subject and a bunch of stuff in the middle, and then a direct object way at the end. And they're actually related, and I know the order and who's the actor who's being acted upon. And this is an analogy. It's not part of the central topic. I remember one example was an article. It was a health article. And it was talking about the bacteria that grows in shower heads in colleges. And in looking at how some of these algorithms processed this page, because it mentioned college students and some medical professors talking about this problem and made references to horror movies, it's scarier than, Hitchcock in that shower scene, right? The statistical processing came back that this must be either college-related or entertainment-related, because it's all a lot of professor and university and college students. And if you just look at statistical frequency, that was the right answer. It had no understanding of the actual content that any of us reading that same page would have said this is absolutely about health. So there's a few language-independent approaches, and I think that this is where the research is going to take us. First is pattern recognition. So this is kind of the brute force approach. You can imagine that if I scanned every book in the world, and there's companies out there that do this, that I could begin finding phrases that appear in those books, and those same phrases that appear on web pages. And if I happen to have scanned a French cookbook and I find a bunch of those same French phrases on this web page, maybe this web page is likely about French cooking, right? And you can use the title or the subject or the genre or any of the manually categorized information about books to now automatically improve the classification of the web. An easier version, if you don't actually have access to all of the scanned books in the world, you could get a dump of Wikipedia and do the same thing. So they've got topics, and they've got a bunch of phrases related to those topics that are the body of the article, and they have some links to other articles, and you can use that to begin saying, if I see these same patterns, it's likely to be about this random web page is likely to be about this topic of Wikipedia. Nice thing about Wikipedia is it's been translated into a bunch of different languages, so it helps get past the language independent. The other nice thing is it's constantly being updated. So if one of the other problems, I mentioned Black Jaguar, but in technology, right, we have the storm, and that could be weather, or it could be a technology gadget. I'm sure every month we have new names of brands that are confusing because they also mean something else. Historically it was something like Apple, and now we are coming up with more confusing things to computers. So the fact that the Wikipedia article would help us disambiguate, because it's going to mention Apple as a fruit and Apple as a computer, and I'm sure there's a bunch of other apples out there, and it'll have other words associated with those to help me understand, is this page really about shopping or farming or about technology? So another nice one is a concept network. So this is the notion, it's almost like bootstrapping. So imagine I used any of the prior methods to categorize content, or at least come up with a taxonomy to help me categorize content. But I'm experiencing new phrases that I've never seen before. And so one use case is, imagine you had only classified San Francisco and all of the things that you find in search phrases or web pages with inverse term frequency associated with this term, San Francisco. You may find restaurants, airport, hotel, parks, a bunch of these common phrases that when people are searching or reading about San Francisco, you find these other phrases. But that was the only city you'd ever classified. Now, if you happen to find another page that was about this random thing called New York, because it has these same similarities, these same linkages to the concepts that a San Francisco had, you can guess that a New York is the same thing that you've classified a San Francisco as. So this is basically how the concept networks work. They're starting with just a self-organized map of co-occurrences, and then based on your manual approach or taxonomization or identification of this is an important node in my network, then it will say, all right, you've labeled the San Francisco thing a city. All the other things that share those connections will also be called a city. And that works pretty well. So that's a nice way to improve your categorization, not have to go manually classify all the cities or go find lists of all the cities and all the computers and all the other genres that you would want to understand. So now let's talk about the visitor side. So people ask, all right, what is behavioral targeting? And I've been doing this for about 12 years. And when I used to talk about this, we didn't call it behavioral targeting back then. In fact, we struggled to describe what it was we did, and we never got past what is a cookie, because this was way back in the early days when content was king and people had no clue. It was all magic of how information was flowing around the web. But if we look at what in essence is behavioral targeting, that kind of is a definition that spans all the different forms, and we'll talk about those forms in a second. It really is helping marketers reach the right individual with content based on previous activities. So if you're marketing to them based on the current page, right, this current context, that's a lot of what Google does today with all these search listings and Bing, of course. But when you begin to look at these patterns, then you can begin to disambiguate. And in the example I gave earlier with the black jaguar, if you only looked at my phrase, I could be interested in zoology or I could be interested in autos. But as you begin to string these things together, you can begin to guess, I know that this individual happens to be more interested in autos than zoology at this particular time. So if I've got any comparison websites or any articles or news events, maybe that's what I should be showing. And I've also heard this, so speaking of search while we're here, I've heard it described as long search. So if you think about Google today, it's still kind of a fire and forget mechanism, right? My first search is black jaguar. And I get back some listings, I click, and then I wind up back at Google, and now I say cheap black jaguar, or used black jaguar, or some other refinement. But every time I do that, I have to help Google remember what I was doing. Now they're getting smarter, but it's still very one-off as opposed to task-based. So a better example would be if I'm planning a trip, right? I want to go to New York, and I want to find a city, hotels in the city. I want to find restaurants, and I want to find some entertainment in the evenings. Right? Google is not basically helping me plan, or Bing for that matter, helping me plan this long search of what I'm actually doing, which is trying to complete this whole task. So the company that Apple bought, Siri, I don't know if you guys ever saw that demo, great demo, but that's a task-oriented view of search, which I hope gets permeated more widely. But it would basically guess what your overall task was and help and have some memory associated with what you were trying to do and help you accomplish that task. And it's more like the promise of a personal assistant that all these portable devices were labeled as when they first came out. So what are the different forms of behavioral targeting? So it really breaks down into a few key buckets. One is how many events, how many of those prior events are you looking at? If it's current event, right, it's contextual targeting. If it's one prior event, then it's some sort of behavior, it's previous behavior. And the simplest form is actually called retargeting. So this is when I want to show a visitor some piece of content related to what they used to be looking at. So this is typically done when I abandon a shopping cart. So it's actually not just one event. I lie a little bit. It's really one event and one non-event. You added to cart and you did not yet purchase. So there's 1 plus 0, which is still kind of 1, so bear with me. But it's the simplest form of behavioral targeting, but you'd imagine that it's actually going to be the best. And the reason I say that is not only has this visitor actually expressed through their behavior, this is the product that they're interested in, but they've told you the retailer as well. I want this thing, I've added it to this cart from this retailer, and the reason they abandoned may not have been because they didn't like it. Maybe they had to run for the train, or they picked up a call, or they went to play with their kids. And there's many reasons why they abandoned that shopping cart. And just reminding them, hey, you just added this to cart. You want to come back and purchase it? A lot of people actually do. So it's one of the highest response rates. And there's whole companies that's all they do. Is they just help with marketers with this retargeting of finding visitors who had previously added to cart on their retail website and help bring them back. So that's kind of the simple one. The more complicated ones are now we're not just looking at one event or one event and non-event, but multiple events. And when we begin doing that, there's about 4 main approaches that I'm aware of. And I'm sure smarter people will come up with some other approaches. So the first that really hit the scene was clustering. And this is really kind of a carryover from the offline world. So if people have heard of prism segments or mosaic segments, in the offline world, the people in direct mail had to deal with 50,000 zip codes, or 1.7 million zip+4s. It's about that order of magnitude. And so they wanted to somehow group all of the US into these custom buckets, so they didn't have to constantly list off, here's the 1,000 out of the 50,000 I'm talking about. They would group them together, and we came up with terms like soccer mom. Right? And that's the one that people tend to use a lot. And in the online world, we now talk about gadget geeks as well, because we're in the online world. But it's a nice approach in that it's very simple for marketers to understand. It's small set. It's usually less than 100, usually closer to 30, sometimes up to 60. And a bunch of companies have their own segmentations of the universe, and every visitor is classified at any given moment into one and only one of these clusters, which is kind of the problem, that at any given moment, you belong to one and only one cluster. You are only a soccer mom, not a gadget geek, or you're only a gadget geek, not a soccer mom. And of course, there's many who are both. Most people have more than one interest. So while it is useful to understand from a marketing perspective, it unfortunately is not as useful from a consumer perspective or a response rate perspective, because the other problem with it is you better hope that the way they've segmented the world matches with what products you're trying to sell. The way I'm going to segment the world for Jaguar may be very different than I'd segment it for Coke or Nike. So that's kind of the issue with clustering. People figured it out relatively early, and so they came up with this business rules approach. So this is the standard Boolean logic that everyone says works on paper, but has a hard time explaining in English because we tend to misuse words when we're using these and not and or not type phrases. But the business rules approach overcame the fact that everyone was classified in one and only one bucket. Now you could be a member of, you've been to my site 3 times in 5 days, you're a member of segment A, and you've added to cart and spent more than $100 in the past, you're a member of segment B. So now, all of a sudden, we could begin to target people based on more than a single interest at a time. The problem with this one, though, is people, marketers love the idea of ultimate flexibility. And when this first came out 7 years ago before Hadoop, this was a really hard problem to say. You can write any custom, Boolean logic statement, and I'll tell you how many people in a short number of seconds, or maybe a very small number of minutes, how many people are eligible to meet this criteria. It was a really complicated computer technology problem to solve. The problem, though, is the marketers liked the flexibility, but they didn't know what rules to program. Is it 3 events in 5 days or 5 events in 3 days? I don't know. And most marketers wouldn't know, right? And the way you figure it out is you test and you constantly iterate. And the problem was that the web keeps changing. So you did your experiment, you did your A/B, and you found it really was 3 events in 5 days. But it's a week later, and all of a sudden those events that you were measuring, it's now different websites or different articles on those websites. Or people have changed mindset, and it's a different set of people looking for things. And so because it's such a fluid, dynamic set of parameters that we're trying to write these rules for, it was really hard to keep up and really hard to figure out and very manual and very expensive. So people searched for other approaches. So then some smart folks said, well, what if I kind of let the data speak for itself? What if you tell me what's good? Forget about defining what you think will lead to someone being good. Just tell me what is good. They purchased, or they added to cart, or they've spent more than 10 minutes on my website, or they've liked my brand a number of times, or told their friends about it, whatever the good event definition is. And then I'll go look at what other information I have associated with these IDs, and I'll do some lookalike modeling, and I'll find other people who may not have done that good event yet, but they share a lot of the same characteristics as the good people. So this is lookalike modeling, and a variant of that is the social graph. Instead of looking at the behaviors, they look at who are you connected to. I remember talking to one of these startups, and they were still in beta when I was talking to them, and they were talking, I'm going to target all of the friends of people who click on ads. And I said, that's ridiculous, right? If I buy a flat screen TV, all the people that I am friends with, they're not in the market for a flat screen TV just because I buy one. And I threw it back at them. I said, take a look at you and your friends in your neighborhood. How many of you own the identical car to all your friends or your neighbors, right? Where people have lots of different interests. I can't believe this would ever work. And unfortunately for me, it did. Fortunate for them, right? They're retired and living at the beach. But the reason it worked was actually twofold. One reason that kind of makes sense from a marketing perspective, one that kind of makes sense from a technology perspective. So from the marketing perspective, just because I'm friends with people doesn't necessarily mean that they're in market, but it may mean they can afford what I'm looking for. So it's a very good socioeconomic surrogate of I'm probably friends with people who graduated from college or can afford to buy a flat screen TV if I've bought one, right? And that type of grouping together actually worked very well in finding people Not necessarily that they were in market, but if you're starting with random, this was better than random. So that was one reason it actually did work, even despite my expectations that it wouldn't. The second reason that it works quite well is that online, there's a bunch of research people who write robots and spiders. And not all of them declare themselves as robots and spiders. Some of them want to trick all these web servers, and they try to mimic real people. So it's very hard to detect all these robots. In fact, they consume a lot of the ads. And the nice ones, raise their hand and say, I'm a Slurp bot, and I'm here, to build an index. But many of the robots out there are generating a lot of page views and consuming a lot of ads, and they're never going to buy anything, right? So if you could somehow filter them away, then you're going to get the same positive results on the top in the numerator, but all of a sudden your denominator is going to be a lot smaller. So your overall success rate is going to be a lot higher. And it turned out that very few robots have Facebook pages. So this was a wonderful robot filter. So that was another reason.
If you're a robot in here, don't listen.
So that was kind of the lookalike modeling approach. Let the data speak for itself. There's a fourth version, which is, if you look at kind of the previous three, they're more descriptive and kind of grouping people together based on their past activities. And the reason we're doing this is in the hopes that in the future they'll do some good activities. But really all the data we're looking at is you're similar to other folks in the past. The predictive intent one is actually just trying to predict what people are likely to do in the future. So the example is if you go and consume a lot of sports content, then you may be interested in sports content, but you may not actually be interested in buying Nike shoes or buying NFL tickets. If I can look at what are the patterns of activity, the people who do these good events, and then weight them accordingly, I can now begin to have some scoring models. So it's not just that I'm similar, it's actually I'm likely to, so it's not binary, it's now kind of a vector of I'm more or less likely to respond. So that's kind of the 5 or 4 different versions, depending if you break out retargeting, from the behavioral targeting approaches. So now that we've figured out how to classify all the content, and we figured out what are the approaches to grouping together all the users, we need some identifier to pin onto all these concepts that we're coming up with, all these interests that we've gone through all this hard trouble to generate. And there's a few of them out there. So the one that people hear a lot about are cookies. And cookies have 2 main functions. So one is storage, and the other is state. So the storage is originally, we needed a place for the web server to store information so that every time I checked a new message on my email, I didn't have to re-log in, right? It wanted to authenticate me and make sure I'm the same person, so it stored some sort of ID in a file located on my client. And that's the real reason cookies were born. And I use the analogy, which I didn't create, but I liked, that really the web is designed like 50 First Dates. I don't know how many people have seen this movie. It's a very funny movie about a woman who can't remember. Every day she wakes up and has no memory of the day before, and so a gentleman is trying to date her, and every day he has to re-win her affection. And kind of the web is like that. Every time you came back to a website, it said, gosh, I have no idea who you are. Do you want to log in and read your email? And you would log in, and it would post back an email, and next email, hey, I have no idea who you are. You want to come read your email? So the state helped remember, oh, all right, you don't have to remember that I just logged in. In fact, you can now start remembering some preferences. So if people remember the Yahoo stocks, I love that function. Used to be able to keep all that stuff in a logged out state. They've now reduced that functionality, and I wrote them an email about that. I was very upset. So that's one way of remembering all this information, is you store it in the cookie. The problem with that is you really had no idea how many of these cookies were still out there. People are upgrading computers all the time, or they're deleting their cookies. So it's very difficult. I've stored all this information in these cookies, but I don't know how many of these cookies are actually out there. In fact, we still don't. So what people began to do is store it on the server. And then they could actually run a count and say, okay, I've already classified 1 million people as soccer moms and another 1 million people as gadget geeks. And I've got that sitting on my database, and the only thing I need is this ID now stored in the cookie. I've got a similar ID stored in my database, and I can now tie these 2 things together. Another way of doing that, of course, is just URL session-based. So you've often seen, if you look in the URLs, the parameters, you'll see session ID equals, and they'll have some random number or alphanumeric text. That was useful, especially in the mobile world, where not all of the carriers would pass along cookies. So the problem, it works fine, right? When I generate some content with a link, I assign an ID to it, you post back. When I post a response, I maintain that linkage. The problem with that, though, is as soon as you navigate away from me and you come back the next day, you're not seeing that same ID. I've forgotten it again, because that's how our web is designed. So another approach that people took was looking at the IP address. It seemed like a good idea, because that's how the content navigates and hops around. Unfortunately, they're dynamically assigned and rotating all the time. So in the future, every device may have a persistent ID, but we're not there today. So the IP addresses are not necessarily the right way to be tracking all this stuff. The fact that many people share the same IP address. AOL was this horrible company to all the website analytics vendors back in the day that, if you looked at where your traffic was coming, a third of your traffic was coming from Reston, Virginia. And all of the AOL traffic was coming through just a small set of IPs that were all registered in Virginia. You can never get behind that to figure out who was coming to your website, what were they interested in, what type of content should you do, or where should you advertise to attract more of them. So IP address is not really a great ID in Europe, they believe. It's personally identifiable, and we'll talk about that in a second. But I think that there's reasons why it should not be classified, and I think a court case recently up in Washington came up with that same opinion in relation to a Microsoft case. So another ID is a device ID. So this is where your actual phone or tablet is got some hard-coded ID and is able to communicate that out through the clients so that it's got this persistent ID. That would be great. That works. There's people who are architecting surrogate versions of this. So look at the fonts that are installed on your computer, and they'll look at the technographics that come through. So what operating system and what browser version. And if you string enough of these characteristics together, you can come up with a relatively unique ID to the device. So that kind of works. But of course, people are updating their devices all the time. And so you probably want to have some sort of cross-device mechanism at some point. So that kind of brings up subscriber IDs. So now if I actually am inviting the user to help authenticate, this is how we check our mail, right? We say, this is my email address, this is my subscriber ID, and you can have other forms of subscriber ID. In the mobile world, there is a technical term called the subscriber ID, and actually a lot of people rotate these. So it is, in essence, a semi-persistent device ID. It may last for 30 days, and then they'll rotate it. But that at least helps. Remember back in that cost per action model, where I've got to remember I showed someone an impression on day one, and they converted 5 days later. I need somehow to monetize that inventory to provide all this free content. I need some way of stitching these events together. So these are a couple of the ways that people do it. And then, of course, I need a transport mechanism. So when the web server is serving out ads or content, it has the right to read and set cookies. Now, other web servers can't read and set that same cookie. It's only the web servers associated with this domain. So a way to transfer information across domains is a beacon. It's also called a pixel. If you don't like the technology, you may call it a web bug. Some people call it an invisible GIF because it's, in essence, usually an image file. It's an image request that is set to be 1 pixel high and 1 pixel wide. And in all intents and purposes, it is invisible. Its only job in life is to transfer information from one page to the other. So when we're talking about retargeting, this is how these companies collect the data off of that add to cart page so that they can then retarget this anonymous ID somewhere else on the web. I think we've covered everything about the identifiers. So the unfortunate news is cookies are very fragile. So this chart takes a little bit of explaining. If you looked at a month of traffic, so this came from an ad network. It was a client of mine. I can't divulge the name, but this was a month of their traffic. And if you look at the cookies, so a lot of cookies are set by devices that reject cookies. So back to our 51st dates, every time I see that device, I say, nice to meet you. Here's a cookie for you, 1, 2, 3. And they come back a second later, and I say, nice to meet you. Here's a cookie for you, 2, 3, 4. And if they're rejecting the cookie, I'll treat them as a brand new device that I've never seen before on that basis. So if you look at all of the cookies online, a vast majority of them are by these people who are rejecting cookies, because every event that they generate is a brand new cookie. So you can't start with all of the cookies as your pool. So I started with the cookies that I saw on 2 days in a 30-day period. So I know that they're not rejecting cookies. So if you start with them, you've seen them on 2 separate days, and you look at beyond 2 days, well, 37% of them will never come back. So you saw them on 2 days in a month, and you never saw them again. So then I said, all right, well, okay, maybe these are people who delete their cookies. They're just lazy, right? And they delete them slowly, and that's why it's such a high churn rate. So what if we looked at people who we've seen for 7 days out of a month? So if we looked at 7 days out of a month, then we're down to about 18%. So that's sounding more reasonable. About 18% of the people are somehow, their cookies are disappearing about once a week. So then I said, well, let's look at it 2 weeks. And then it dropped to 14%. And then for probably small data reasons, it went back up to 16% if you looked at them for 3 weeks. But on average, you can see it's in the 14 to 18% range of cookies are churning for people who are actually accepting these cookies and not actively deleting them all the time. So they're very fragile. And as I mentioned, people are trying to overcome this. Kind of some of the other methods is inviting the user to opt in and self-authenticate. And you've seen some of the social network with OAuth trying to say, I will use my Yahoo login to authenticate on Facebook or vice versa, and now you can help personalize content to me no matter where I happen to be online, so long as they're also subscribing to the same service. Which brings up privacy. So the analogy I like to use with privacy and all this data collection is a highway, because we're talking about traffic and recycling exhaust and whatnot. So in my perspective, privacy hinges on identity. So if we've got a traffic camera looking at all this traffic zooming by, I personally love Google Maps. It tells me what is the average speed on given days of all the cars flowing down the highway. And when there happens to be an accident, maybe I should take a different route. And it's a very useful service. And it's all aggregate, and it's all anonymous. Now, if that same traffic camera was actually looking at my license plate and identifying I was speeding, and then radios ahead to a cop to pull me over, I might have a different view of that same data collection traffic camera. So likewise, I believe in the online world, when we're collecting all this data, it's not the collection mechanism where everyone focuses. Oh, you're collecting cookies, or you're using web bugs or invisible GIFs. It's not really on the collection. It's really on what is the use. Are they trying to identify you, or are they trying to use this in some anonymous aggregate fashion? And we've seen in the self-regulatory guidelines, so if you do want to do some research, behavioral targeting is also called online behavioral advertising, or interest-based advertising is Google's name for it. Same thing, it's all behavioral targeting. It's all generating these interests or these guesses into what people may want based on their aggregate and anonymous behavior. Because at the end of the day, marketers don't market to first names. We went through the one-to-one marketing. It's just not cost-effective for them to do it. They had to do it in the offline world, right? To send me direct mail, or for calling me in the middle of my dinner, right? They needed some personally identifiable information. But for the online world, it all runs on anonymous and aggregate data. Now, Facebook and some others may say, no, we really do want people to raise their hand, self-identify, and have a direct relationship and on a name basis with brands and advertisers. But the majority of the advertising that's happening off of those sites doesn't need it. So it brings the question, how many pieces of anonymous data does it take to personally identify someone? So there's a study done, I think it was out of University of Pennsylvania, where there's actually been a few of these cases, right? The famous one in the New York Times, AOL released some data for researchers to try to look at their search logs, and the New York Times, out of the 100 and some odd thousand or million, rows of this data set, they were able to identify some people in the real world, and they knocked on their door or called them on the phone and said, were you searching on AOL on this date, for this thing, and they said, how'd you know? Right? And AOL said, no, we anonymized all the data before we sent it out. There's no way anyone could do it. Well, it turned out people were actually searching on their own name or their own address or their own telephone number or their own social security number. New York Times went to one of these data companies and said, can you please tell me who lives here, what's the phone number associated with this name? And they began calling him up. Are you the John Smith who was searching on AOL? And the first guy said no, and the next guy, were you the John Smith? And eventually, if you go through enough John Smiths, you'll find the right John Smith. But the interesting thing is, the New York Times still had to guess. They still had to have the person self-authenticate. Yes, that was me in that search log, not the other John Smith. Because it was still an anonymous, I could have been searching on John Smith, right? John Smith said, no, it wasn't me, and he would be right. And the New York Times never would have found that I was the person doing the search on John Smith. So really, the answer to this question is it's impossible without some merger to a PII source. So if the person themselves self-authenticates, says, yep, it was me, that's one way of doing it. But from the anonymous data set alone, it's really impossible. So I'll mention one more. Yes, question? Sorry, I should have explained. Personally identifiable information. So these are things that uniquely identify someone in the real world. Your street address, your phone number, your social security, credit card, anything that can be, I can pay someone to uniquely identify you and find you in the real world. It's called personally identifiable information, and there's a whole bunch of legal, there's laws associated with this in various industries trying to say, this data is very sensitive and must be treated in certain ways. Another question? Yeah. Yeah. Mm-hmm. Yeah. I disagree. So I don't know about that particular case, but I do know about the Netflix because there was a researcher who said, all right, I'm going to take this Netflix data set that's also been anonymous like AOL, and I'm going to go look at public postings. People who publicly say, on various places, I think it was IMDb is the source that they used, and they found that the people who said, I love this movie and I hate that movie, and they looked at the data in Netflix, they're pretty, after 10, 20, 50 movies, they began to match them up. Now, the reason I disagree with the statement is the people were publicly posting. They were saying, I love these, I hate these, and they've associated their name. Had they anonymously posted, there'd be no way to match between these two data sets in an identifiable way. So in that particular instance, I'm sure their colleague approached them and said, are you the person in this data set? And she said, yes. But she self-authenticated. If she had said no, I doubt that they would have actually been able to say, I know you're the only person who likes these movies.
This is almost true by definition, because if you include location data, you can get down to somebody's house or whatever.
Yeah, so location brings up an interesting twist on this. So normally with online data, even at zip level, it's very cut and go. So I don't have the exact figures, it gets better all the time, but I want to say it's around 80% accuracy at zip. At zip plus 4 in the online, this is now down to sets of households. For online advertising, for all this digital advertising, I don't think anyone is able to do that at scale. So if you're self-authenticating, if you're registering with a website and giving them your address and in the terms and disclosures of the publisher, then sure. But I don't believe that that's actually going on scale today. But you're right. If you're targeting, Apple got into trouble for tracking all of the location without disclosing that they were doing this. Now, I don't think they were actually using that data to serve advertising. But when you get down to tracking where someone lives, then that may be personally identifiable because it's tied to a street address, which by definition is personally identifiable. So let's talk about the future. So, in kind of Web 1.0 world, is all this content, and it was a race to get content and attract all those eyeballs. And it was really the content linking to content, and we as consumers read and began to buy stuff online. And then we figured out that there was a lot of content out there, and we needed some help. So search came to the rescue, and it helped link people to the content, and began, the new thing was, real-time search, and we began to be able to do this faster and faster. And then came the social networks, right? And that linked people to people. And all of a sudden, you could begin liking content and explain to all your friends. And that's kind of almost, where we are today. Where we're beginning to go is to location. So where I think the next frontiers of all of what we've been talking about is using the same information or the same methods to actually collect where people go in the real world or what people buy with their credit card. So I know we have some experts from the mobile landscape and commerce landscape in the audience, but I believe that the same sort of information of content personalization or helping bring interesting or likely to be useful content to my doorstep that we've seen in the online world, we'll soon be seeing in the offline world. So an example might be, if I'm going on my trip to New York, and other people from my area have been on a trip to New York, the places that I shop where I live, and the places that they shop where they live, and then where they went in New York, maybe those would be places I'd want to go in New York. So the same sort of information and processing that we're talking about with the online data now can be used with offline data. And to me, this is really the future. This is, as far as I know, no one's doing this at scale, but I'm sure there's many startups that have some very nice ideas about how to link people to places and also their commerce. And that is the end of my talk. Thank you.